In this video, we're going to look at the proof of DeMoivre's theorem. So if a complex number z is equal to or by the cos of theta plus I times the sine of theta, then z to the power of n, or complex numbers to a power, is equal to the modulus to the power of n, or to the power of n, multiplied by the cos of n times the angle n theta plus I times the sine of n theta. Or it can be written in this form: the whole complex number to the power of n is equal to the same thing. So we're going to use a proof by induction here, which you may have seen before. So we're going to show true for n equal to 1, assume true for n equal to k, and then we're going to prove it's true for n is equal to k plus 1. So let's look at n is equal to 1. So we'll use this one here. So that means that or by the cos of theta plus I times the sine of theta to the power of 1. And it's the whole thing. So that's equal to, anything to the power of 1 is just equal to itself. That's equal to or by the cos of theta plus I times the sine of theta. And if we now put n in here, so this is the left hand side, I suppose we could call this the left hand side. The right hand side over here, is that equal to or to the power of 1, where this n becomes 1, by the cos of 1 theta plus I times the sine of 1 theta, and you can see that it is. So the left hand side equals the right hand side, therefore true for n is equal to 1. So we're going to assume, like all these proof of inductions, assume true for n is equal to k. So therefore we have or by the cos, sorry, using the left hand side here, the cos of theta plus I times the sine of theta, all to the power of k. That's going to be equal to this guy, where n becomes k, or to the power of k by the cos of k theta plus I times the sine of k theta. So now we have to prove true for n is equal to k plus 1. So replace your n with k plus 1, or your k with k plus 1. So we're going to have or by the cos of k plus 1. I don't want to mix up the left and right, I'll keep to the left first. Or by the cos of theta plus I times the sine of theta to the power, all to the power of k plus 1. We have to show that that's equal to or to the power of k plus 1, this k becoming a k plus 1, by the cos of k plus 1 times theta plus I times the sine of k plus 1 times theta. So anything to the power of k plus 1, we can separate the power, so this becomes or to the power of k by the cos of k theta plus I times the sine of k theta. That's the k part, that's or to the power of k. We'd have to multiply that by the 1 part, so or to the power of 1 by just the cos of theta plus I times the sine, or 1 theta, the sine of theta. If you want to just see where this is coming from, it's or by the cos of theta plus I sine theta, all of that to the power of k times or by the cos of theta plus I sine theta, all to the power of 1. When we say, should have probably written that first when we separated the powers, and then we get to this line here. So now we just need to multiply them. We have or to the power of k times or to the power of 1, these two, and we have the brackets multiplied, so we have cos k theta by cos theta, the first by the first, plus cos k theta by I sine theta. And then we have plus I sine k theta by the cos of theta, and then we have this plus I by this plus I, so we're going to have plus I squared, which is minus 1, so minus sine k theta sine theta. So now if we bring the real parts together, these two real parts, we're going to get these two is r to the power k plus 1 by the cos of k theta cos theta minus sine k theta sine theta, and you can see that that's cos A cos B minus sine A sine B, and then we have these imaginary parts, so plus I times cos k theta sine theta plus sine k theta cos theta. And that's cos A sine B plus sine A cos B. So if I write that underneath it, so it's the connection between trigonometry and complex numbers, which the French mathematician Abraham DeMoivre, who was born in Champagne, came up with in his lifetime, and this formula is named after him. So we have cos A cos B minus sine A sine B plus I times the sine of cos A sine B plus sine A cos B. So I think it's good maths to write this out, so when you go to the formula booklet you can see exactly what you're looking for. So r to the power k plus 1, so write down what cos A cos B minus sine A sine B is the cos of A plus B, and RA is k theta and RB is theta, or the other way around, it doesn't really matter, and then plus I times, and cos A sine B plus sine A cos B. In the tables it's sine A cos B plus cos A sine B. That's going to be the sine of A plus B. So r to the power k plus 1 times the cos of theta plus k theta, the two angles added, plus I times the sine of theta plus k theta. And you can see here we have a theta common to both, so if I factor out the theta, I'm going to get r to the power k plus 1 by the cos of, up here we have the theta written outside, don't we? This one here with the theta on the right hand side. So if I just factor out the k plus 1, just to match them up, I have the theta on the right plus I times the sine of k plus 1 times theta. Just one bracket too many there. That's the end of the proof. So therefore, true for all values where n is an element of natural numbers, we can say for this one. No, it is true, not just for natural numbers, it's true for all values, including fractions, but in the exam we just have to prove true for natural numbers. So that's DeMoivre's proof, or DeMoivre's theorem. Learn it off. Make sure you're able to do this with your, not with your eyes closed, but maybe with your eyes open.